The TU Delft Hydromotion Team 2023 will win the Monaco Open Sea class with a foiling hydrogen-powered boat. That's the goal we set at the beginning of the year, and that's how we'll end the year. Welcome to our design presentation, everyone. Thank you all for being here. I'm Isabel de Bruin, team manager of this year's team. Today, we'll reveal our design to you and explain how it contributes to a more sustainable future. To start, I want to take you back to a small artist village in Zeeland. It's called Kat. I spent many summers here building tree houses and collecting apples from the orchard of our family home. This all looks very charming and peaceful, right? But it was differently in 1953. The dike you see in the background had collapsed, just like in 150 other places in the Netherlands. To prevent the Netherlands from future floods, the delta works were built and the dikes were repaired. But is this enough? The answer is no. Due to climate change, the sea level is estimated to rise 1.2 meters by 2100. Not all dikes are able to cope with this amount of rising. With this sea level rise, our small country will look like this. The rising sea level is a result of climate change. Last month, the United Nations Framework Convention on Climate Change was hosted in Egypt to look for possible solutions to tackle climate change. One of the outcomes was to offer loss and damage funding for vulnerable countries severely impacted by climate disasters. But will this fund be effective? Isn't prevention worth more than curing? The root cause of climate change must be tackled, and that involves reducing emissions. And that is where the maritime industry can be part of the solution. For the last few years, the previous teams have been inspiring the maritime industry to move to a more sustainable future. And they made the industry aware that these technologies exist. This year, we are going to turn the tide by moving the industry to implement sustainable technologies now in order to limit the CO2 emissions. So, why are we actually focusing on the maritime industry? The answer is actually quite simple. Look around you for a moment. The chair you're sitting on, the clothing you're wearing, the bright lights that are shining. Have you ever considered the journey that these travel to reach you? 90% of the things we use daily are transported overseas for our use. In the globalizing world economy, the need for sea transportation is constantly increasing. Even though sea transportation is considered the most efficient way of transporting goods, it is still responsible for 2% of the total global CO2 emissions. If no emission control measures are implemented and no mitigation policies are set up, this amount is expected to be double the current one by 2050 as a result of this increase in global trade. Ships have a 20 to 25-year operating life. That means we need to start building ships this decade to limit the CO2 emission. So imagine the impact we could bring about if we improve the sustainability of the maritime industry. We are the TU Delft Hydromotion team, a team of 23 multidisciplinary students. We show the opportunities in the maritime industry to tackle today's and future climate challenges by pushing the boundaries of sustainable technologies. The TU Delft Solar Boat team was founded 17 years ago to explore new, innovative and sustainable technologies. In 2006, the first edition of the Solar Boat was built with the goal of winning the first edition of the Frisian Solar Challenge. They indeed win this race and thereby achieve their goal. In 2010, the team started using hydrofoils, these are like wings, of an airplane for the first time. In the following years, the teams focused on optimizing the placement of the foils and making the boat more and more efficient. And this all led to great success. We became world champions in 2019. In 2021, we saw the possibilities of hydrogen and made the transition to become the TU Delft Hydromotion team. The team decided to refit the old 2019 hull. They removed the solar paddles and added a hydrogen system. And this boat became the first foiling hydrogen-powered boat in the world. Last year's team managed to design, build, test and race a whole new boat for the use of hydrogen, with which they won the Endurance Challenge. They sailed almost twice as far as their competitors. This truly shows the potential of hydrogen, and this year we want to take it a step further. However, we, as the 2023 team, cannot do this alone. Each year we explore new, innovative and sustainable technologies together with the knowledge of industry experts and the experience of alumni. To start, we will build our boat by combining the expertise of our partners together with our own freshly acquired knowledge. In this way, we use their expertise to show the potential of hydrogen. Together with our partners, we want to make a positive impact on the world of tomorrow. Also, alumni help us along the way. By joining this team, you're not only becoming a group of students working together towards a common goal, you're becoming part of this whole network of ambitious and passionate alumni. And in this way, we build upon the knowledge of the previous teams. And seeing the amount of alumni who are here today clearly shows the strength of our foundation. We all want the same thing. Together, we want to sail to a sustainable future by turning the tide.
We are the TU Delft Hydromotion team, a student dream team that shows opportunities in the maritime industry to tackle today's and future climate challenges by pushing the boundaries of sustainable technology. Each year, we assemble a completely new team, which builds its own innovative boat. We do this in order to go through the full design cycle as engineers and be able to fully optimize the boat without restrictions. To boost innovation in each year's boat, we can count on a network of alumni.
We build on the knowledge of the previous teams. This way, we don't reinvent the wheel, but we can continue to innovate. On the technical side, we analyze what has been done in the previous years, so we can improve upon this with the assistance of alumni. Next to technical knowledge, alumni gained a lot of experience in navigating through such a big project in their year of working together as an independent team. Moreover, by working closely together with alumni, we also get to know them on a personal level, resulting in lifelong connections.
Alumni not only ensure that we can innovate, they also help us to reach our goal. While we are learning to become engineers for a sustainable future, they already are. After their hydromotion year, they continue to spread the sustainable mindset they have developed wherever they go. And we will follow in their footsteps.
I've never worked together in such a way with such driven and motivated people. We've really put our all into it for a whole year, and we really do mean something to people from the industry as well.
We just want to push the envelope. We want to prove something is possible, and by us doing it, they can integrate the things we learned, the things we experienced, such that they can more quickly adapt the sustainable technologies, and in such a way that we accelerate the transition to, in our case, hydrogen as a fuel for the maritime industry.
I've seen that it's really important that the marine industry develops into a sustainable way, and I'm studying marine technology, and also in my master's I try to pick the courses that really works towards a sustainable future.
I think our common goal is moving ourselves towards a more sustainable future, and really setting the standards for that. Being young as well, we're already now setting the standards, and are all hoping to take that into our work as well, I think.
And by incorporating the alumni still, the team, the foundation as a whole can keep on growing instead of starting over each year.
We can see how this team still develops and still helps the maritime industry, and next to that, how every team member who has ever part of the foundation will have an impact in the company where they will be, and hopefully every one of us will play an important role in the sustainable future.
Because only together we can turn the tide.
With the help of our partners and alumni, we'll take the next step in bridging the gap between technology of the future and the current norm. In just 1 year, we will design, build, test, and race a foiling hydrogen-powered boat. To put our boat to the test, we'll participate in the open sea class of the Monaco Energy Boat Challenge. This event aims to stimulate the creativity of tomorrow's engineer and the industry to develop propulsion methods using sustainable energy carriers. Here, we are going to excel in speed, maneuverability, and endurance to become world champion and prove that rapid, sustainable innovation is possible. At this event, we will be the only student team to compete and will race against industry professionals. So, over the last 17 years, we have built amazing boats that sail on sustainable energy sources. We wanted to inspire the maritime industry to move to a more sustainable future. But now, with our design, we do not want to just inspire anymore. We want the industry to start taking action. With our design, it is time to turn the tide.
I want to introduce you to Aurora, our boat, named after the Roman goddess of dawn. It will fly above the waters and draw everybody's attention with its good-looking shape and streamlined body. I am Ruben van den Bos, the chief of this year's Embedded Systems department.
And I am Frank Stapelbroek, the chief engineer. Together, we will explain the technical features of our boat.
Aurora's shape might seem familiar to you. Just like last year, we will build a boat made of one body. We will make many innovative improvements, and though the outside might look the same as last year, we will have many adjustments to the design to make the performance even better. One of our main goals this year is to fly the boat above the water. And for that, we are paying a lot of attention to making the boat as light as possible.
One of the adjustments we will make is the hull design. We have collected knowledge from alumni and partners to make the new design. The middle of the hull is wide. This is to ensure that we can place our wings as far apart as possible. In contrast, the rear and the front of the hull are quite slim, and this is to reduce resistance. One noticeable feature of the boat is a small, almost horizontal part on the bottom side of the boat. It is there to ensure that the hull will leave the water smoothly when it's transitioning from sailing to foiling. In order to make our hull as lightweight as possible, we have optimized its shape and are going to make it out of carbon fiber. This means that the hull will weigh around 77 kilograms, around the mass of Ruben. Not only the outside, but also most of the inside will be made out of carbon fiber. For example, the plates that run across the hull. They are there to add additional support to the hull to ensure that it stays together. With the finite element method, which is a computer simulation that can predict the strength of our boat, we have calculated where exactly this support is needed. One example of components that need extra support because of their mass are the components of the hydrogen system.
Isabel already explained that we want to push the boundaries of sustainable technologies. And one of the ways in which we achieve this goal is by making use of hydrogen. Hydrogen is an excellent energy carrier. It can carry a lot of energy compared to other sustainable fuels. One of the problems with renewable energy sources is the supply and demand mismatch. And hydrogen can be the solution. I will now explain how. In the afternoon, all of our solar panels are generating green energy. Around 5 o'clock, everybody starts cooking. But now the sun is suddenly gone. To provide the energy needed, some big power plants start up. But this is the last thing that we want, since these big power plants use fossil fuels, and they endanger our environment with the greenhouse gases they emit. We need to store the sustainable energy during the afternoon so that we can use it in the evening. Luckily, we can store the solar energy in hydrogen, using a process called electrolysis. In this process, electricity is used to split water into hydrogen and oxygen. The oxygen is released back into the air, but the hydrogen, which contains a lot of energy, can be stored in tanks to be used at a later moment. Aurora carries 2 of these tanks, which can store 16 kilograms of hydrogen. These tanks, they are really strong because the hydrogen is stored at a pressure of 350 bar, which is 350 times the pressure we experience in the outside air. If we would let all of the hydrogen out of the tanks, it would take up the volume of 17 city cars. By storing the hydrogen at such an enormous pressure, we can store a vast amount of energy. At top speed, and with only 16 kilograms of hydrogen, we can sail a total distance of 400 kilometers, which is 4 to 6 times as far as our competitors. Unfortunately, our electric motor cannot use the hydrogen directly for its propulsion. For that, we make use of a fuel cell, which is a device that does exactly the opposite of the electrolysis process. It creates electricity out of hydrogen again. Although the whole fuel cell looks very complicated with all kinds of components and tubes, the basic working principle is quite simple. The device combines hydrogen and oxygen and converts these into electricity and water. And one of the biggest advantages with hydrogen is that it does not emit dirty exhaust gases when it is converted to electricity. The pure water that is produced can be directly disposed of in the sea. After the conversion of hydrogen with our fuel cell, we can use the electricity to propel our boat.
And our boat will be propelled by an electric motor, which is quite compact, but can still supply a lot of power. The motor connects to a long stainless steel shaft. The shaft is so lengthy because our propeller is more than 1 meter below the waterline. 2 gears transmit the force from the motor to the propeller. And this propeller is custom made for the speed and drag of our boat to ensure the highest efficiency possible. The propeller is attached to the hull through vertical pillars called struts, which we will make out of aluminium. In total, we will have more than 3 struts in our boat, to which also are 3 wings attached. And you can imagine that these would need to withstand enormous forces when foiling at our top speed. That is why we have performed extensive simulations on them to make them as lightweight as possible, but for them to also being able to resist these forces. Of course, we don't only want our boat to go straight forward, but also to be able to make turns. The fastest way to do this is by turning the propeller, and for this, actually, the whole strut needs to rotate. That's why we have designed a part that attaches on top of the strut that rotates it. The motor is also held in place by the system. It is moved by gearing cables that run all the way to the front of our boat, where our steering wheel is located. So, let's start spinning the propeller and begin sailing. When Aurora reaches a speed of 25 kilometers per hour, something extraordinary happens.
The boat suddenly rises out of the water and starts flying. The foils that are attached to the struts underneath the boat create an upward lifting force in the water. These foils stay in the water at all times to make sure that Aurora can stay in the air. You can imagine that the resistance that the boat experiences drops drastically since the hull no longer has to displace the water. This will increase our speed to a top speed of 50 kilometers per hour, which is the same speed as the speeding water taxis in Rotterdam. An additional benefit is that the boat no longer slams on the waves, so that the pilots can have a smooth sailing experience without any bumps. There is one problem, however. When rising out of the water, Aurora becomes very unstable. If we would not actively control it, the boat would immediately fall back in the water. For this reason, we have a height control system on board. Multiple sensors measure the height and angle of the boat compared to the water. And this data is then used to control the actuator motors, which are located above the struts. These motors then finally move the foils using cables running through the struts. We have explained how we create electrical power. That is, by converting hydrogen to electricity with our fuel cell. We have also explained all the different components we need in our boat, and a lot of them need electrical power.
We have one box in our boat that controls the entire electrical system. You can compare this box to the fuse box in your own home. It is located all the way in the front of our boat, so it can be accessed by our co-pilot. With switches on the box, we can individually turn on and off the electrical components in our boat. This is to ensure that our boat is as safe as possible. This box and all other electrical components are connected to each other by electrical cables. And in total, we have more than 90 of these cables. This year, we have made a convenient data structure to keep track of these cables. And with that, we're able to use an algorithm to compute the most lightweight and efficient cable plan. The thickest cables of our boat run from the fuel cell to the motor and the batteries. And now you may wonder why we still have a battery, since the electricity is made out of hydrogen, right? Well, we use these batteries in situations when the motor needs a lot of power. So, for example, when it wants to take off. So when it's transitioning from sailing to foiling. In this case, the motor draws energy from both the fuel cell and the batteries. Later, when the motor needs less power, the fuel cell charges the batteries again.
The batteries, motor, and fuel cell work on a high voltage because this is good for efficiency. Besides these high voltage components, we have a lot of auxiliary components that work on a lower voltage. You also have that in your car. Think, for example, about the air conditioning or the navigation system. In Aurora's cockpit, we find a small low-voltage battery, and its purpose is exactly the same as the 12-volt battery in your car, to start up the system. However, the energy in this small low voltage battery is not enough to power all low voltage systems. That's why we convert the high voltage power coming from the fuel cell into lower voltage power using an innovative and lightweight converter. Our converter this year will have a mass of only 1.7 kilograms. One of the systems that uses a huge amount of this low voltage power is the cooling system.
This is because a lot of components in our boats produce heat. These components would break in no time if we would not intervene. And this is why we have such an extensive cooling system. Multiple cooling loops containing very clean water flow through the boat. They flow through the components that generate heat, such as the battery, motor, fuel cell, and converter. These components cool themselves by heating up the water. Next to that, salt water is pumped up through the struts. Unfortunately, we can't directly use this water to cool our components, since the salt water would corrode the metal parts. That's why the salt water flows through heat exchangers, through which also the warm, clean water from the components flows. Then the salt water cleans the warmed up clean water without mixing. This cooled clean water then again flows through the components, and the salt water will get pumped out of the boat. So in the end, we have tubes in the strut that pump up the water, and other pumps will ensure that it will get pumped out of the boat in the rear. In this way, we ensure that all components stay at the appropriate temperature at all time.
We are super proud to have finally shared our design with you. Now it's time to welcome Isabel back on the stage.
Thank you, Frank and Ruben, for walking us through the technical features of our boat. This design shows what a highly motivated and ambitious team can achieve in just 1 year. I am super proud of the team, and it's time to put them in the spotlight. Let me introduce to you the 2023 Hydromotion team. Ga maar. Ja.
Four months ago, we started as a group of 23 strangers. We all had different study backgrounds, different hobbies, and different reasons to join the team. But we all had one thing in common: the intrinsic motivation to combine our knowledge to show that rapid innovation is possible and necessary. We all put our studies aside for 1 full year to go after this dream. Through this shared ambition, we became a team in no time.
I want to be part of the solutions for a sustainable future.
I want to develop my engineering skills.
I want to learn to work in a big team.
Every day we use products that are transported overseas. We are all currently heavily reliant on fossil fuels, for example, for transport. These fossil fuels are part of the cause of our current climate problem. Luckily, there are sustainable alternatives such as solar energy, wind energy and hydrogen, but we do need to start implementing them now. We will go to the Monaco Energy Boat Challenge with a foiling hydrogen-powered boat built by a group of students in just 1 year. This is the place to be, where sustainable technologies from all over the world come together and where we can exchange knowledge on our shared dream. Moreover, we will show the potential of hydrogen by winning the open sea class of this competition. This way we will bridge the gap between the technology of the future and the current norm to encourage people to start taking action.
Over the past months we've been working hard on taking the first step towards realizing this dream, the design of our boat. We came up with ideas, we created concepts with the knowledge of our alumni and partners, and we worked out every detail to come to the optimal design to win the race. But this is only the first step. We are not there yet. We will continue building our boat and testing it to become world champions.
With our team and our design, we will bridge the gap between the technology of the future and the current norm. However, we cannot do this alone. Follow us on our journey to a sustainable future. Because only together we can turn the tide.
We, as a team, design, build, test and race a foiling hydrogen-powered boat in just 1 year. With this, we prove that rapid sustainable innovation is possible and that you can do something now to turn the tide. We want to thank everyone that makes it possible to do this, from partners to alumni, but also everyone that's present here today. By being here today, you've also contributed on making a positive impact on the world of tomorrow. Because only together we can turn the tide. Thank you. Ja. Ga maar. Nice.